I told you is nice, you see it, right? But here is more real global, real reason. Let's look at it. I want to find the expectation value of Pauli matrix on the Bloch sphere. Again, how do you find the expectation value of an operator? And first of all, what is the meaning of expectation value? What's the other terms for expectation value? Yeah. What is the other term? What do you call it? Mean. Very good, right? So I toss the dice. I ask myself, what is the expectation value? Well, you say I expect many things can be 1, 2, 3, 4, right? So the meaning of expectation value is the mean. So what is the mean of a fair die when I toss it? What's the expectation value? What's the mean? Anyone know? My dice has 1, 2, 3, 4, 5, 6. So what is the expectation value? Say again. So it becomes probability, right? For example, I have a dice. The expectation value, if it is unbiased, when I toss it, now so this good, you guys don't gamble. So how do you find it, right? Experience means the mean, right? First, you want to, what are the possible outcome, right? And then what is the probability of getting the outcome, right? So what are the possible outcome? It can be 1, can be 2, right? Can be 3, can be 4, can be 5, can be 6. But what is the probability of each of these outcomes? Yeah, 1/6. So each of them is 1/6. If you have a biased dice, then maybe higher probability for 1, you just put higher probability for 1, right? And what is this? Should be 3.5, right? Just average. Just the average value, right? We're asking the expectation value is just average. So yeah, it is strange, right? The expectation value is 3.5. You never expect something come up with 3.5. I mean, the dice never give you 3.5, but my expectation value is because it means it's the mean on average. That's what I get, right? So the question here is, what is the expectation value of sigma z, right? Of sigma z, when I try to find, when I try to do a measurement on the when I have the wave function that is psi of sigma z for psi. Well, of course, we talked about this before. Of course, it's the probability of getting 0 times 1. When you get 0, what is the eigenvalue of 0? 1, right? The eigenvalue is 1. How about when the state is 1? What is the eigenvalue? -1. Okay, so can we play with this? What is the probability of getting 0? Maybe you don't see it, right? I need to write a wave function for you. The wave function is like what we say, cosine theta divided by 2, e to the power negative I phi divided by 2, 0, plus sine theta divided by 2 e to the power I phi divided by 2, 1. Right? That's what we derive. What is the probability of getting 0 based on this? The square of the coefficient. Very good, right? So the square of the coefficient is cosine square e to the power negative I phi divided by 2 square. I'm taking the magnitude times 1 and then minus, because it's times negative 1, of sine theta divided by 2 e to the power I phi divided by 2 square. Do you agree? This is just alpha, this is just beta. But what is the magnitude of e to the power I something? It's just 1. Well, this is the envelope, similar to envelope of unity, right? It's just a unity. This is a unity, right? So because of this, the expectation value is cosine square theta divided by 2 plus sine square theta divided by 2, not plus, right? Should be minus. I'm so scared. If it is plus, then it's always 1. Is that okay? What is the meaning? You cannot get the meaning yet. I need to give you an equation. This one equals to cosine theta. This is given. Trigonometry identity. If you remember from your trigonometry, that is great. If not, I don't require you to memorize. Okay, sine square theta minus cosine square theta equals to cosine 2 theta. Here I have theta divided by 2. That's why it becomes theta divided by 2 times 2. Is that okay? What is cosine theta in this figure? I have a point. It is away from the vertical axis by theta. Cosine theta is just the projection of my point. Or actually, I have this here already. Maybe just do this. This is also theta. Cosine theta is just the height of this one. It's just the projection of the state onto the vertical axis. Do you see that? Yeah, because this is theta, right? So if you make a vertical line to here, perpendicular line, that is projection on the vertical axis is theta, is cosine theta. Now, do you see this is something related to a real 3D space now? It turned out that if you want to find the expectation value of the wave function that you are interested in, the expectation value is just equals to the projection to the vertical axis in our real 3D space. For example, if your state is 0, what is the projection of it on the vertical axis? 1, right? Because you're just on the top of the axis. If your wave function is 1, the projection is what? -1. Right? It's just on the south pole. Right? And if you are on the equator, what is the projection of your onto the what's the projection onto the vertical axis if you are on the equator? If you are here, for example, what's the projection to the equator? To the vertical axis. 0. No length, right? But no worry, you talk about FH, it just say that you measure it many times, your FH value is 0. So this is the first use of Bloch sphere. Very clear. The sigma z projection I mean, sigma c expectation value is just equal to the projection of that vector you saw on the Bloch sphere, right? But again, this is not a vector in the 3D space because 0 plus 1 not equal to nothing. 0 plus 1 is equal to a state. But when we do the projection, we treat it as a vector, then the length is the expectation value of the sigma c. Okay? We can use another method to do this, just to practice the math, right? Instead of doing this probability, we use a quantum mechanical method, the math method, right? It is equal to psi sigma z psi, as I told you earlier. That is the expectation value, correct? Now, then how do we do it? We need to make it into a matrix form. The bra, what is the bra form of the psi? Maybe I start with sigma c, that would be better. What is sigma c? 0? No. What is that? 1? 1, 0, 0, minus 1, thank you. How do I write the psi in this case? Cosine, good, theta divided by 2 e to the power negative I phi divided by 2, right? Because this is the coefficient for 0. The bottom is psi theta divided by 2 e to the power I phi divided by 2. Okay, that is easy. But how do I write the bra? Is it a column or a row vector? It should be a row vector, right? So what is the first element? Cosine theta divided by 2n e to the power I phi divided by, why not negative I phi divided by 2? Complex conjugate, right? You need to be very familiar with this, right? Even now, I sometimes make this mistake. And then I find out my calculation has problem. Then the second term will be sine theta divided by 2 e to the power, what is that? Minus I. Yeah, thanks for helping me to answer. Because again, complex conjugate, right? You just go through the math. Maybe I can go through this quickly. Just from left to right. How do you do multiplication? Row times column, right? So what is the first column? It's going to be cosine theta divided by 2 e to the power I phi divided by 2. That is the first element. Then negative sine theta divided by 2 e to the power negative I phi divided by 2. The whole thing times the column. Do you see what I'm doing here? This one times this one, right? Row times column. So I only have cosine theta divided by 2 e to the power I phi divided by 2 left, because this is 0. Then this row times this column. Yeah, 0 is gone. Then I have negative sine theta divided by 2 e negative I phi divided by 2. Any questions? I know this is simple for some of you, but let's review. Is that okay? Okay, then finally, I'm going to multiply this by this. Should I get a matrix, a vector, or a number when I do this multiplication? Number, right? Because it's a row times a column. A bra times a cat. So it's an inner product, right? So this equals to, if you just go through the math, because I'm going to have cosine times cosine, right? I did not copy this one. This equal to this, right? Cosine times this one plus sine times this one. But I have negative sine. But the good thing is, do you see that the e to the power negative I phi and e to the power I phi got cancelled in the first term? Same for the second term. So you get cosine square theta divided by 2 minus sine square theta divided by 2. Exactly the same as what we had before. And use the identity, trigonometry identity, we get cosine theta. Right? This is just a practice. But the main point here is to show you that, again, the expectation value turns out to be just the projection to the vertical axis. Make sense? Any questions? If no, let's keep practicing. Now, how about the expectation value of sigma x? Now this time, I will use this one directly, right? I'm going to use psi on sigma x psi. Okay, so I will write this down, but we already know what is psi, right? We did that earlier. We have cosine theta divided by 2 e to the power I phi divided by 2 due to the complex conjugate sine theta divided by 2 e to the power negative I phi divided by 2. The whole thing multiply sigma x. What is sigma x? 0, 1, 1, 0. Good. Right? You need to memorize. Even though you are not required to, but you should. And then I continue to write cosine theta divided by 2, right? E to the power negative I phi divided by 2, and then sine theta divided by 2, e to the power I phi divided by 2. Right? It's ugly, but you know what I mean. Okay, so I first do the multiplication of the first term, the bra times the matrix, or the row vector times the matrix. What do I get? The first term, this multiply this, right? So this C0 gone. This one times 1. So I actually get sine theta divided by 2 e to the power negative I phi divided by 2. Then the second term is cosine theta divided by 2 e to the power I phi divided by 2. And then the whole thing multiply cosine theta divided by 2 e to the power negative I phi divided by 2 sine theta divided by 2 e to the power I phi divided by 2. Difficult to see. My pen is breaking. But do you see that? Now, I hope that you also don't just think about matrix multiplication. You have some insights to the matrix also now. It is like, what do you call this? Anti-diagonal or whatever, right? It means you're going to swap the element. Now, this is a very important, not important, but you understand this, that at a larger matrix, you have a better insight how to derive your own algorithm, right? So easily, I just swap them. I don't need to do the multiplication that I told you. Now, then I'm going to multiply them, but this time you see that I have the same. I'm going to multiply this by this, so this times this plus this times this. But I have the same sine theta divided by 2 and cosine theta divided by 2. And however, for E, they are not, right? They are not cancelled, right? So what do I get? I get sine theta divided by 2, cosine theta divided by 2. And then I have e to the power negative I phi, because I have 2 negative I phi divided by 2, plus e to the power I phi. Yeah, because this one times this one plus this one times this one. Okay? Do you see any identity that you can use? Anyone remember any identity? Trigonometry identity? Maybe you forgot. This one I do remember. 2 sine theta cosine theta equals to sine 2 theta. Okay? So this one will give me sine theta divided by 2. Right? Because this is 2 theta over 2. Right? This part. Is that okay? And how about this one? Maybe you forgot, but I can tell you, right? E to the power theta, I theta. Maybe I just write here. E to the power I theta equals to cosine phi plus I sine phi. E to the power negative I phi equals to cosine phi minus I sine phi. Okay? So if you add these two together, you get 2 cosine phi. Okay? So this is 2 cosine phi. So the result is sine theta cosine phi. Is that okay? Any questions? But what does it mean in this Bloch sphere? So if I have a state, any state here, right? This is unit length, right? Because it's a unit sphere. What is sine theta? We learned what is cosine theta, right? Cosine theta is the projection to the vertical axis, right? Then what is sine theta? It will be the projection to the equatorial plane. Because this one or this one, they are both sine theta, right? And they're parallel, right? So you just project, I have a vector on the sphere, I project to the equatorial plane. Just think about the sphere. Now we are at San Jose. You draw the vector to San Jose. You project it on the equatorial plane. The length from the center of the Earth to that projected point is sine theta times the radius of the Earth, right? Let's say the Earth is spherical. So this one gives me this length. Not very interesting yet. Remember, this length does not touch the equator. It does not touch the equator. It's inside the sphere, right? And then what? And then I further multiply it by cosine phi. What is cosine phi? It is the projection onto the x-axis. Correct? Because this is cosine phi, right? Because this is theta, you draw a right angle triangle, that is the projection, right? So then it means, again, the expectation value of sigma x for a wave function on this Bloch sphere is just equal to its x component. That's it. That's what you're saying. You equals to the x component in the Bloch sphere. So if I ask you, I point at this point, what is the expectation value of sigma x for this point? What is that? 0, because when you project to there, you project to the 0, right? And then is that correct? It is, because this is the sigma y eigenvalue. It is correct. How about this one? What is the expectation value of this point? Expectation value of sigma x of this point? Plus what? What is the value? 1. Yeah, because it is already on the x-axis. It stays there, 1. And this is -1. which is correct. That is exactly because they are the eigenvalue of sigma x, right? And so no matter how many times you measure, it's still the eigenvalue, so it is 1, -1. Yeah? Yeah? So we already know this is true, but we keep trying. We just want to practice the math. There's no reason, no excuse in the exam that you still do this wrong. Okay, this math, this is a good summary on this basic linear algebra, okay? How about for sigma y? I want to try psi sigma y psi, right? I'm finding the expectation value of psi on sigma y, or expectation value of sigma y when I use the wave function psi, any psi, right? So everything should still be the same, right? Because this is the bra cosine theta divided by 2. And then, anyone has already memorized it? Cosine theta divided by 2, and then what? E to the power, okay, -5, but because this is bra, so it becomes I phi over 2. Okay? And then, how about the second term is what? Yeah, e to the power -I phi over 2, right? And what is y? Do you remember? 0 minus I 0, okay? And how do I memorize it? I know that we need I. Sigma c does not have I, sigma y, x does not have I. Sigma y is the one who takes care of I. And then it is in this direction like sigma x, I. And some people memorize in this way, I learned from somewhere. Negative is smaller, so smaller stuff flow up in the water, right? So lighter, smaller, so flow up. It's up to you, right? So it's -R here, right? And then we just complete the column vector with cosine theta divided by 2 e to the power -I phi divided by 2. This is A, right? Again, this tells us how much of 0 you have. Sine theta divided by 2 e to the power I phi divided by 2. Right? This tells us how much 1 you have. Then we go through the math. This should be the same as the sigma x in terms of math, except now I have I and -I, right? So I will swap them, but when I swap them, I will get an I here. I will get I. How come I swap it this way? Oh, so this becomes very complicated. Sorry, I want to use my method in my cheat sheet, right? So you learn another skill. This is pretty complicated, right? So I can use just something faster, easier to write, and then I convert it. This one I can also write it as A star, B star times 0 I 0 AB. Make sense? Where A is the coefficient, right? Then I go through the math. I will get what? IB star minus, minus, but negative instead of subtraction, IA star times AB. Is this okay? And I continue to do the multiplication, becomes I AB star minus I A star B. Okay? Make sense? Okay, and then I substitute, right? So A, what is A? A is cosine theta divided by 2, e to the power -I phi divided by 2, and B star is sine theta divided by 2, e to the power I phi divided by 2. This is the first term. A is this one. right? A has negative. B star, I should have negative also because it's B star. Okay, and then I continue on the next one. Then I have cosine theta divided by 2 e to the power, because now A star, right? So it becomes positive. I phi divided by 2, and then times sine theta divided by 2 e to the power I phi divided by 2, because B has no star. It's just similar to what we got earlier, but I want to show you another way, right? It might be helpful. So I will get this. I take the I out. I also get cosine theta divided by 2 sine theta divided by 2, right? And then inside of e to the power negative I phi minus e to the power I phi. Okay, so let's repeat what we did earlier. E to the power negative I phi equals to cosine phi minus I sine phi. E to the power I phi equals to cosine phi plus I sine phi. Right, so this is different from the last one was e to the power negative I phi plus e to the power phi. This time is negative e to the power negative I phi minus I phi, right? So if it this the top minus the bottom, what does it give me? The cosine will be gone. Then I have negative 2I sine phi for this part. And similarly, this part is sine theta whole thing divided by 2. And then I have an I also. Right? And then I times I is negative 1. So I have sine theta sine phi, which is expected. Again, what is sine phi? Sine theta. Just like the previous case, is the projection on this equatorial plane. So this is the length. But last time it was about cosine phi, so it's the projection onto x-axis. But now it is further multiplied by sine phi. So it's projection to the y-axis, right? So it's still the same message, which is the expectation value of the Pauli matrix is equals to the state, the projection of the state on the Bloch sphere to the axis on which you apply the magnetic field. When you do the sigma z measurement, you apply magnetic field vertical in the real 3D space, not in this space, but in the real 3D space. When you do sigma z measurement, sigma x, you apply magnetic field in this direction. When you do sigma y, you apply magnetic field in this direction. That is how it is linked to our 3D space. It's not that the state really resides in our 3D space, right? We project it to the 3D space. And then we treat it as a vector. Its expectation value turned out to be just like it was a vector, the projection of that vector on the axis. Okay? Any questions? And of course, I've been giving you the same message, right? You did not learn anything new. These are just practice. So we do the same thing. What if I have a general Pauli vector? We learned this earlier. I don't know if you still remember. It's just like if I apply a magnetic field, for example, in this direction, maybe in another direction. Apply the magnetic field in a certain direction. Okay? And this direction, of course, is going to correspond to a certain vector, which I call it n. A unit vector, right? So if I apply a certain direction, I can say there's a unit vector. That direction is characterized by a unit vector, right? It's just like that. If I say magnetic field is applying vertically, it is the unit vector from here to here. So can you guess what will be the expectation value of psi for this magnetic field? I already told you if the magnetic field is applying vertically, it's the projection to this vertical vector. If it's applying horizontally, it's projection to here. So what do you think? If I apply magnetic field in this direction, what will be the expectation value of psi? Huh? Is it n or? No, think about that. When the magnetic field is applying vertically, the n, where is n? What is n? N hat. When up, so this is the n hat, right? So what was the expectation value? No, I mean the expectation value of psi in that case. I mean the psi is here. This psi is not here, it's here, right? What did we say? What is the expectation value for sigma z? Cosine theta, which is the projection of this vector to the vertical axis. And this vertical axis is the n hat when B is pointing up. Yeah. No, I'm not really latitude. I'm talking about exactly this axis, vertical, not on the surface of the sphere. Yeah, exactly this line. Let me make this clear. So if I have the Bloch sphere and then apply magnetic field in this direction, this is the n hat when the magnetic field is applying vertically. Do you agree? Do you understand what I'm saying? If I have Bloch sphere here and I apply magnetic field in the x direction, this is the n hat when the magnetic field is in this direction, right? And we have been saying that the expectation value of any psi, whether here or here, when you have magnetic field in this direction, what is the expectation value of this psi for sigma x? Is the projection of this psi on the n hat, right? On that axis. When we apply it vertically, it is the projection of this vector on the vertical axis, right? So now if I apply magnetic field in this direction, what will be the expectation value of psi? Is the projection of what? Something like the sum, but not exactly. I mean, I think I know what you say, but you cannot just add them. Yeah, it is the sum. You are right. It is the sum of the projection, the vector sum of the projection. Or in other words, it's the projection along n hat. You also can project to n hat, right? I have an n hat here, and you have this vector. You just project to there, find the inner product. But as you said, yes, it is the sum of the projection to x, y, z, vector sum, but also it's just the projection onto that n hat, right? I just want to say that based on this learning, without the math, you already know that what is the expectation value. Now, this doesn't look like useful in this class, but it will be useful in the future when we deal with complicated systems. You have these insights, then you will be able to do something faster, right? But still, I will go ahead. But probably you forgot the operator we discussed at the very beginning of this semester. The operator is not sigma c, it's not sigma x. Do you remember what is that? It is n, n hat dot sigma vector. And probably you forgot what is n hat dot sigma, what is sigma vector, right? Say again. Yes. But sigma vector is sigma x, sigma y, sigma z. Do you remember I talked about this at that time, not for physics, just want to scare you or like to stimulate you to understand that a vector, as long as it follows the rule, is a vector. So here is a vector with the element being the matrix, not numbers, right? What is this? 0, 1, 0, 1, 1, 0, right? Zero, negative I, I don't know what happened to my pen. Zero, 1, 1, 0, 0, negative I, 0, and then 1, 0, 0, negative 1, right? This is a column vector, but its elements are matrix. No problem. You are allowed to do that because you still fulfill all the vector space definition, all this operation. Yeah? So what is n? N is just a unit vector. And as you say, it's the projection, nx, ny, nc. Right? The x component, y component, and z component of that unit vector. That's it. Now this is a regular 3D vector living in our space. We learned it before, right? But when you do the inner product, n dot sigma, you do the same thing. N dot sigma is just like this. Yeah? So you have nx ny, nc, right? Times the whole thing, sigma x, sigma y, sigma z. Okay? Now, by the way, let me ask you again, when we write in column vector, what is the basis for nx, ny, nc? This is a number. I have nx component of what? And nx magnitude of which component? X hat. Do you agree? This is a 3D vector. Y hat, Z hat. How about this one? I have sigma x component of what? You dare not to answer, but probably you know. If I can multiply them together, they must be in the same space, right? They share the same basis vector, right? What is the component of this? Also x hat. Again, this is a space that you cannot fill, but it's okay. It's just math. Right? So that's why x hat, y hat will get cancelled out. You can do the dot product as usual. Right? So this one, I won't go into the math because of space, and we did that before. This is just equal to n z nx minus I ny nx plus I ny negative nz. Can you make sense out of this? Does this look correct to you? Yeah, because you do inner product, right? NC only multiply to sigma z, which only Sigma z is the only one that has the diagonal component. So you get nc and negative nc. And similarly for nx and ny, right? So this is one element, okay? So I did not follow my cheat sheet. I went too far, but that is a good exercise. But actually my goal is not this, but it's a good exercise. You need to be very familiar with this. Let me continue on the calculation of the expectation value. I just told you that the operator is this. This is called the spin operator, right, in arbitrary direction, which we discussed before already. Now, instead of going to the details, I'm going to change it to this. As I told you, n dot sigma is what? Nx sigma x plus ny sigma y plus nc sigma c. Is this okay? Because n dot sigma is just nx plus nx times sigma x, ny times sigma y plus nc times sigma c. That's the definition, right? So that's why I have this one. Now, again, this is linear. So I can make it to what? Nx sigma, psi sigma x psi plus ny psi sigma y psi plus nz psi sigma z psi. Okay, this one makes sense? Because I add them together, right? This is addition. I can do distribution, right? Nx and y a number, just take it out. And we already calculated all these terms, right? What are these? So sorry, I need to go from here to here. Right, this gives me nx cosine phi sine theta plus ny sine theta cosine phi, sine phi sine phi, not sine theta. NC cosine theta. Okay, so if you look at this, just like what you said at the beginning, it is just equal to the vector sum of all the projection. But if you take the vector into account, you scale each of these projection by nx, ny, nc. This is just equivalent to projection of xi on n hat. That's it. Okay. So the whole purpose here is just go through the math, and I want to remind you the polyvector, which will be useful in the more advanced class. But otherwise, the only conclusion is the expectation value is just the projection of the psi on the unit vector in the direction that you apply the magnetic field. Okay? And that is how it's related to the 3D space. That is the first thing. Okay? Any questions? If no, then now go to the second reason to use the Bloch sphere. Can really help us to visualize many things. Let me see, not here, I need to write it. So, what is a quantum gate again? We discussed at the beginning. It is nothing but just a laser pulse, microwave pulse you shoot to the qubit, and then it evolves, right? What does it evolve? It changes in its hyperspace, right? Because in the 2D complex space, you have many points. Each point is a vector. Apply a gate, it becomes another vector. Then it's just like you are moving in your hyperspace, right? But you cannot see it. But the good thing now is I map the space to the Bloch sphere in our 3D. I embed it in our 3D space. Then when it's moving from one state to another state, isn't that I should be able to see it moving on the surface? So this is a nice way to do that, okay? And this move is that because you are rotating on the surface, there are many ways to do that. One way is the Euler rotation. It's characterized by that if I want to rotate a point from arbitrary initial point to the arbitrary final point, you can do this by 3 rotations about 2 axes. First rotation, rotate about the vertical axis by gamma anticlockwise, if you look from the top. And then rotate about on the y-axis by theta anticlockwise, if you look from the right. And then rotate again from the top, okay, about the vertical axis by phi. Then you can complete any rotation, right? And recall, rotation is just a quantum gate. Then it means any quantum gates can be represented by this 3 rotation that we can visualize. It's not really visualized, but we can feel it, right? And this rotation and this matrix can be written as theta, phi, gamma, which is called the Euler angles. There are many different versions, but we use this one. But remember, when we write this, theta is the second rotation. Phi is the third rotation, and then the first rotation is at the end. This one will be equivalent to applying a matrix of this cosine theta divided by 2, negative e to the power I lambda sine theta divided by 2, e to the power I phi sine theta divided by 2. And then e to the power I lambda plus phi cosine theta divided by 2. And this normal, you can see that I can form any 2 by 2 matrix, complex one, by using this parameter. But the reason we use this is the theta, phi, and lambda correspond to how we rotate it. We can see it very clearly in the Bloch sphere, right? The writing is not good, so what? This one is funny. They always erase my stuff, right? So let me say again, rotation equals to quantum gates. And then the matrix I won't write it, I just say C, next page. I won't write it again. Okay? So here on the top right, I have the matrix. So how do I find out how to rotate a gate? For example, I give you a NOT gate. Again, what is NOT gate? NOT gate is just sigma x. 0, 1, 1, 0. Okay? How do I rotate? Many of us, including myself, the first thing is that, no, just rotate about y from top to bottom. Isn't that not okay? Then you will go back, right? But however, this is only for one special case. We need to look at this carefully. We need to find out theta, phi, and lambda that satisfies this equation. Cosine theta divided by 2 negative e I lambda sine theta divided by 2 e to the power I phi sine theta divided by 2 e to the power I lambda plus phi cosine theta divided by 2, where I just copy from here and I wrote earlier in the last page, right? Although it got erased. What do we need to do? You need to equate them, find out what are the theta, lambda, and phi that give you this matrix. Okay, so I'm going to equate the elements one by one. First, 0 needs to be equals to cosine theta divided by 2. Then what is theta? What is theta? That will give you cosine theta divided by 2 equal to 0. Pi. Because pi over 2, cosine pi over 2 equals 0. Okay, pi. Okay, fine. Then I'm going to equate the next term, negative e to the power I lambda sine lambda sine theta divided by 2. But you already told me that theta is pi. So this is e to the power I lambda times sine pi over 2 by 2, which is 1. And it needs to be equals to what? 1. How should I pick lambda so that this equals to 1? Same again. What did I do wrong? Sorry for that. Let me do it fast. NOT gate again equal to 0, 1, 1, 0. I don't write that one. I just to equate it. The elements, right? And I already told you that when you have 0, it needs to be equal to cosine theta divided by 2. So theta equals to pi. And then we do the second one. 1 needs to equal to negative e I lambda sine theta divided by 2. So, which is equal to negative e I lambda. It needs to be equal to 1. Right? So what will give you 1? Unless e to the power I lambda equal to negative 1. Right? So it is pi. Am I right? Yeah, so lambda equals to pi, right? Because e to the power I lambda equal to e to the power I pi equals to cosine pi plus I sine pi, which is equal to negative 1. Okay? So I have lambda, good. Then how about the next one? I have 1 equals to e to the power I phi times sine pi over 2. Again, theta is pi over 2. I'm talking about this term and this term, right? So then it means what should theta be now? E to the power something equal to 1. What should be phi be? E to the power what equal to 1? 0. Okay? So then the last one, we can check if that is correct because you need to satisfy all the condition, right? We check the last one. 0 must be equal to e to the power I. You say what is lambda? Lambda is pi. Phi is 0. And then cosine pi over 2. Oh, what is cosine pi over 2? 0, right? So this is correct. Okay, so we form the gate. What is this gate? Lambda equal pi, theta equal pi, phi equal to 0. Look at this. A NOT gate is, first, you need to rotate about the vertical axis by pi because lambda is pi. Looks meaningless to you, right? I'm on the North Pole. When I rotate pi, no change. Then I rotate about the y-axis by theta, second rotation by pi. So I go pi, I go to 1. Then again, the third rotation is say phi equals 0. Don't rotate. So this indeed is a NOT gate. Then you may say, and here I try to implement this this one on IBMQ. I use, instead of using the NOT gates, I use the pi 0 pi, which is just a general 1 qubit rotation. This one start with 0, right? So after this NOT gate, I should get 1. This one start with 0. After first NOT gate, I get 1, and then another NOT gate, I should get 0. So I get 1, 0, just to show you that it works. Yeah. Any questions? So finally, let's take a look why. The point is this. When you want to construct a matrix, the Bloch sphere help you to visualize, but also can be misleading, making you doing something wrong. Because when you talk about a NOT gate, naturally, we will just think that rotate about the y-axis, then I will get the NOT gates, right? 0 to 1, 1 to 0. But 0 and 1 is a special case. If you do that, it might not do the same thing for other general qubit. For example, what is the NOT gate of plus? What is the NOT gate of plus? What is NOT plus? Do you know? What is NOT plus? Also plus. Very good. Because you are not. Yeah, someone will say minus. I would guess so also if I don't think carefully. But now if you write it down, not this one, you just not individual of them, right? So you get 1 plus 0, right? Which is still plus. Yeah, although you swap it, but both of them are the same, right? Can you say again? Z. Yeah, Z gate may change, but now I only look at NOT gate for now. Yeah, it's the same, right? If you just think about rotate it by pi, because we keep thinking NOT gate is rotating pi, right? Starting from here, rotating pi, what do you get? You get negative, which is wrong. This is wrong. But if you look at our scheme, first, rotate about z-axis by pi, then it becomes negative. Then rotate about y-axis by pi, it becomes positive again. Then do not rotate, becomes positive. Okay, just a message to you when you see the Bloch sphere, do not just come up with a rotation scheme right away. You need to go through this mapping. Okay, that's the main message and know how to do it. Okay, so that's it for today. Any questions? Yeah.